let's go to problem 6 here. 2t minus 7 less than 4 parentheses 3t minus 5 plus 6t. All right, well, with inequalities parentheses, same thing as earlier. We want to get rid of the parentheses first. We've got to distribute the 4. Multiply 4 times 3t is 12t. 4 times minus 5 is minus 20. And then the plus 6t doesn't change. It's not in the parentheses, so it just stays plus 6t. Combine the like terms on the right. I've got 12t plus a 6t, so that's 18t minus 20. Get the t's on one side, the constants on the other, so I'm going to subtract 18t from both sides. And I'm going to get the constants on the other, so I'm going to go ahead and add 7 both sides. And I wind up with negative 16t minus 7 plus 7, that's 0, is less than negative 13. Now notice, I did subtract and add something to both sides, but that doesn't change the inequality. However, next step here, I'm going to divide by negative 16, and yeah, that's where that rule kicks in. Divide by both sides by negative, you've got to change the direction of the symbol. The less than becomes greater than, and so on the left I have t, negative 16's cancel out, greater than, divided by negative, so it changes, and then negative divided by negative makes it a positive 13/16. So that's greater than, t is greater than 13/16. All right, there are a couple of special solution sets, and numbers 7 and 8 are going to have examples of that. Well, take a look at this one. 5t minus 6 is less than 5t plus 7. 5p plus 7, excuse me. 5p minus 6 is less than 5p plus 7. Okay. Well, if we go about solving this, I'm going to subtract 5p from both sides. Note what happens. Well, 5p minus 5p, that's 0, so just have minus 6 on the left. 5p minus 5p is 0, so it's 7 on the right, and I've got less than 7. Direction doesn't change there. Well, with the variable going out, what I wind up with here, negative 6 is less than 7, which that's always true. Which we've seen that happen on equations before, but what about inequality? Well, the same thing basically happens in an inequality that happened in an equation. If it's always true, the solution set is all real numbers. Now, it just so happens that, yeah, all real numbers, that's an always true statement, and any number for p would satisfy this inequality. So it's all real numbers. Now, we can write that in now our interval notation. All real numbers, well, that's, well, graph-wise would be the whole number line. So if we graphed it, it'd just be shading the whole number line there. But as far as interval notation, couldn't we say that's negative infinity, positive infinity? It points both infinitely to the left and infinitely to the right. Yeah, negative infinity, positive infinity. So if you get an always true statement, that's what you do with that. Now, on number 8, 8 minus 7, parentheses x plus 5 greater than 10 minus 7x. Well, distribute our negative. So that's 8 minus 7x minus 35. Minus 7 times x minus 7 times 5. It's minus 35. It's greater than 10 minus 7x. Let's see, combine my like terms. 8 minus 35 is negative 27. So I have negative 27 minus 7x is greater than 10 minus 7x. get the variables on the left here, so we're going to add 7x, but what winds up happening is I get negative 27, negative 7x minus, or plus 7x is 0, so it's just that. It's greater than 10. Well, in this case, I get negative 27 greater than 10. That's not always true. That's actually false. Never true. And we had something like that happen in an equation. When that happened in an equation, we said solution set wise, there's no solution. Same thing for the case of an inequality. No solution, solution set here. There is not an x that we could substitute in that would satisfy that inequality. And so the graph, the number line, well, you just wouldn't put any shading on it at all. It'd just be a number line that's not shaded. All right, well, last thing I wanted to cover in this particular section was another type of inequality, and that turns out to be the three-part inequalities. We saw those earlier and talked about what it means when we get the answer here, but how do we solve three-part inequalities like this? We haven't got x solved for here. Well, turns out what we do, all we have to do is get the x, or the variable, whatever the variable is, in the middle all by itself. So we want to isolate the x in the middle by itself. Get the x in the middle by itself. All right, well, to do that, I'm obviously going to have to add the 3 off. The thing about it is that they do have 3 parts, so to maintain the balance, so to speak, I've got to add the 3 to all 3 parts. So when we have two sides, we've got to do the same thing to both sides. Well, 3 parts, you've got to do the same thing to all 3 parts. So here's what we get. 7 plus 3 gives me 10. Is less than 5x, because minus 3 plus 3, that goes to 0. And then on the right side here, I've got 14 plus 3, that's 17. All right, well, trying to get x by itself in the middle, so divide by 5. Well, like I said, you got to divide by 5 on all 3 parts. Divide by 5 in the middle, and on the left, and on the right. Okay, so that gives me 10 divided by 5, 2. In the middle I have 5's canceling, so it'll just be x, and that's 17/5. All right, well, that's what we talked about earlier. When we get the x by itself in the middle, what that means is the part of the number line I'm talking about is the part of the number line between 2 and 17/5. So that's solving a 3-part inequality. There is one other problem I wanted to mention, one like this one. A little something different happens here, but not too bad. Again, we've got a 3-part inequality. So I want to get the x by itself in the middle. So what I need to do is, first of all, subtract 2 from the middle. So I got to subtract 2 from the left and the right. Also, negative 4 minus 2 is negative 6, less than or equal to, and then of course the 2 minus 2 is 0, so that just leaves me minus 8x is less than or equal to 16. All right, now I have to divide by negative 8, all 3 parts. But hopefully there you were thinking, hey, I'm dividing by a negative, so all these inequalities have to reverse, and they do. As well as simplifying here, well, negative 6 divided by negative 8, the negative divided by negative is positive. And then, of course, here we just get the x. 16 divided by negative 8 is negative 2. One other thing I can do is reduce reduce those down by 2's. So I'll wind up with 3/4 greater than or equal to x greater than or equal to -2. All right, well, first of all, let's note that, for one thing, I've got the order kind of mixed up here. I've got 3/4 here and -2 here. Well, in the number line, -2 would come before 3/4. That's one thing to note. They kind of reverse around there when we put them on the number line. The other thing is, well, which part are we talking about? Are we still talking about between? What are we talking about here? Well, again, if you look at the two parts, I've got x greater than or equal to -2, which is greater than is this side of -2, and then I've got 3/4 is greater than or equal to x. Well, again, we like having the x on the right there, so let's flip-flop those around, and the inequality's got to point towards the same thing, which is point to the x. So 3/4 is greater than or equal to x is the same as x less than or equal to 3/4. So I'm talking about the less than side of 3/4. So hey, look at that. I am talking about those two combined between -2 and 3/4. So it does mean the same thing. I've got the equal to part on 3/4, so that's a bracket. Got the equal to part on the -2, so that's a bracket. So yeah, same thing, interval notation, -2, comma 3/4, bracket, bracket.